Assalamualaikum, myself Muhammadullah, and today we are going to do examples of seventh chapter and ninth chapter. This is our first problem in which we have to write ABRC program to send 0 to FF to port B. So here's the code for it, and it's schematic layout. On running, you can see these LEDs are blinking because 0, 0, 0, 1, 1. These are going away and away. Now moving toward the second question. In the second question, we have to write a program to send hex values of ASCII with character 0 to D to port D. And this is a code for it. We will gonna run it at 10 times to send 0, 1, 2, 3, 4, 5, 6, 7, 8, 7, whatever between them, and A, B, C, D. Because there is no delay, so we will directly move toward the last unit, that's D, and D have binary 0100 and 0100. So 0100 and 0100. Hence it's verified. Next, moving towards 7.3. In 7.3, we have to write we are programmed to toggle all bits of LED on port B or on 200 times. So we will gonna add this for loop of 200 times. This for loop will be gonna run for 200 times, and then the LEDs will gonna be toggle. Toggle means to change themselves from each other. Now moving toward 7.9, it's 7.9 in which we have two LEDs are connected to pin port B, and we have to count 0 to FF. FF means the last date means 11111111 from 0000 and 0000 means the LEDs will gonna start blinking from 0 to 1111. This is the code where there is a delay, so we can't get the target too fast. Still, you can see 0000, then 11 000011, then 1000. It's counting plus 1 and moving on. Now moving towards 7.11. In 7.11, write an AVR program to get a byte data from port C. So we will we are going to use switches on port C, and port C means from port PC0 to PC7, and if it is less than 100, then we will send it to port B, else we will go the LEDs which are connected to port D. And port C, B and D mean PB0 to PB7, and port D means obviously PBD0 to PD7. So these are the switches. We are going to run this code. First of all, see this code. This is the code we have set C port as input, where we have connected the switches, and B and D port as output, where we have connected the LEDs to show our output. If our data or byte is less than 100, it will gonna send to port B, as it will gonna send to port D. So on running this code, we can see that I will gonna this LEDs will gonna glow like it was glowing before. Um, like this. So this is the data which is less than 100, so it's we are sending it to port B. If this data will be greater than 100 or equal to 100, it will directly gonna be shown on port B LEDs. Now moving toward 7.12. 7.12. In here we have to run the given code. This is the code where port B, port C, and port D are output and 0x35 with 0x05. We will gonna explain this code here. Bitwise of The AND function of 0x35 and 0x0f is 0x05, which is 101. Others are given here. You can see them. Mm, here you can see them. After it, while one, there's no need for while one. You can also deduct this from the code. Now, running the code, you will gonna see soon. Yes, these are all those conditions which we have added and divided and as an used as an XOR and NOT operation. All are given here. So now moving towards 7.17. In 7.17 we have to write the code in which we are going to add toggle logic toggle to give inputs as 1 and 0 binary inputs and issue an ASI characters on output, and we are going to decide output on port D where we are going to connect LEDs from PD0 to PD7. The output on LEDs will be according to the code which will gonna send from 0, 1, 2, 3, and 0, 1, 2, 3 is the ASCII. So they have different forms in 0x30. You can see in this code. These are the form case 1, case 0, case 2, case 3, and we will gonna send to port D 0, 1, 2, 3. 0. It's not given here, but still you can know that two of IDs are always low in this case. See, if I change these two IDs will always gonna glow because 0, 1, 2, 3 are common in them. Now moving toward 7.24. Here's the question of 7.24, where we have to get status of bit 5 of port B and send it to port 7. We have to connect the LED on port B, pin 5, and send it to PC 7. So here's we are going to get input on port PB5 and going to get output on PB7. Here's the code. It's the one of the most easiest code in this whole chapter. And on running it, you can see if it's 0, it is not blinking. If it's 1, LEDs will gonna be high. So now moving on the 7.25. In 7.25, there's a door sensor which is connected to the PB1 and LED is connected to port C. Right and APR to monitor the door sensor, and when it opens, turn on the LED. It's same as your question number 24, where we have connected an input, one binary input to PB7 and an LED to another port. So this is gonna be same as the previous one. We are going to skip it and moving towards 7.26. In 7.26, write an enable program to convert pack BCD 0x29 to ASCII and display the bytes on port B and port C. We have to connect the LEDs from PB0 to PB7 and PC0 to PC7, and we are going to convert BCD 0x29 with them. We have here's the source code where we have defined the code more. Here explain the code more and more, whatever we can explain here. So first of all, we convert the BCD digit to ASCII and send it to port B. Then we have extended the upper four pairs. Then we shift right by 4. Then convert the BCD digit to ASCII and send to port C. And here's the running code now. These are the LEDs of port B and these are the LEDs connected to port C. Now moving toward 7.27. 7.27 Write an AVRC program to convert ASCII of 4 and 7 to packed BCD and display them on port B. This code is also same as the previous one of 6.26, so we are not going to explain it here. You can contact me and I will gonna discuss with you in the class. Now moving towards 7.31. In 7.31, you can see write an AVR program to convert 111101 to decimal and display the digits on port B, port C, and port D. Here's a simple thing that you can see. This code is the one of the second most used code in this chapter. We have used bin byte as a temporary digit collector and PB used and assigned PB and assigned port B, C, and D as an output ports. In bit byte we have stored 253 in decimal. Then by divided by 10, our answer will be 25, and divided the then divided that same answer with 10 will gonna be 2, because first we expelled for 3 and now we are going to remove 2 at the end. I mean 5 at the end, and the answer will be 2. Other hand, d1 is equal to bin by divide percent 2. In percentage we will gonna take remainder, which will be gonna be 3, and then another reminder of bin by divide by 10, which was 25. 25 by 10 2, because we are going to remove the last digit. So then assign maybe port B to D1, port C to D2, and port D to D3. And here's the output you can see. In these are the outputs, because this is 2, this is something else, this is something else. Now moving toward question number 7.34, the last question of this chapter. In this chapter, in this example, we have to write an ABR program to bring byte of data serially one bit at a time via port C. This means we will gonna use a single binary operation on any one pair port. Here's the given port, which is pin 3. Pin 3 is the serial port, but it's not a serial port in at mega 2560. It's only a serial pin in at mega 3 to 8 p, but still we have used here. Maybe it will gonna work, maybe not. The least significant bit should come in first. So here's the code, the simplest code. There's no need to explain it. Moving toward the schematic layout. Here's the schematic layout where we have attached PB0 to PB7 LEDs. There's no need to attach these all LEDs. It will directly gonna show same output on all of them. So you can directly gonna attach only one LED to any of the port of any of the pin of port B. Yes, there are 8 pins, so we can use any of them because all of them are same outputs. We're gonna take our inputs from port C, pin 3, and directly gonna show us on any of the LEDs of port B. So now moving toward the next chapter, chapter number 9, and the first code 9.39. Here's the chapter 9, 9.39. So in 9.39, we have to write a program to toggle all the bits of port B. So toggle all the bits of port B means to toggle, for example, if they are 0, then we will toggle and make it 1. Continuously with some delay, we will gonna add a delay with it using timer 0 normal mode and no prescaler option. No, prescaler mean 1024 is not coming here to divide it by 1024. There's no need to divide it. Here's the source code for it, where we have declaring port B as output port and then repeat it forever 0x55 making port B 0x55, and there is a little delay, then again repeating it forever. This is a simple code for timer 0 normal mode, no prescaler, where the we have to clear T0 V0 at the end. That's the name of register. And here's the code. These LEDs are blinking. But due to PWM combinations, there's little lighter brightness control, not a proper blinking. So moving toward the next question, 9.40. In 9.40, we have a proper specifications for timer 0, and it is totally gonna be prescaler 1:8 prescaler. It 1:8 means we have 8 cycles, and we have to divide it using it to 16 megahertz as our at mega 328p and at mega 2560, which are standard in our books, are using 16 megahertz oscillator or crystal. So we have to calculate according to it. Here is a code. It's a simple code. We have to attach a simple LED on port B pin 4 and to test the, here's port B pin 4, and we are directly going to test this blinking. Here's this blinking. Now moving toward 9.41, the next question. It's same as the previous one almost. Just the difference between that and this is time, which we're gonna calculate separately. Other than the code is totally same. You can see here's the difference game. So other than it will gonna work almost same, just a little faster due to the delay time. Other than the code is almost same. Now moving toward 9.42. In 9.42 we are going to use timer 1, same as the upper one, so there's no need to discuss it. Moving toward 9.43. In 9.43 we had to connect counter on port C and port D. But the disadvantage by that we have to get the square wave generator, which we don't have. So then it coming toward the next one. Here we also need square wave generator, but still I can show you how it looks like. So we have to create a circuit like this for it, but because we don't have a function generator currently, because my Proteus have some fault due to which I don't have a function generator, so I can't run it. Other than this, you can see the code is totally correct. We can compile it F7. But there is nothing running, so we can't run it with the function generator, and my Proteus doesn't have it. Anyway, best of luck for exams. Allah Hafiz. We will gonna meet in our next video.